Good morning, everybody. Hopefully, you all are doing well. It's morning for me, so actually slept in a little bit later than I thought I was going to this morning. So, it's a fun morning. I have a little bit of a headache. We're trying to chase it away with some coffee, so we'll see. We'll see how that works this morning. But if you are watching live, say hello in the chat. If this is your first time, let us know where you're from, where you're watching from, and um, and of course, if you are sitting there with some sort of beverage, water, wine, I don't know, whatever it is you're drinking, coffee. If it's like me, maybe it's coffee and it's in the middle of the night for you, and you can do that. I don't know that I could do that, but say hello and join me in our quick drink of the morning for me. Oh, that tastes. Actually, it doesn't really taste anything. I don't know, but it's nice and warm, and hopefully it'll help warm up the old vocal cords this morning. So, in case you're watching for the first time and you keep seeing me look over here, it's just checking to make sure things are working well on the live stream. I've noticed that when I've gone back and rewatched some things, it looks weird and maybe a little distracting at times. So hopefully it's not too big of a deal for you. But I just like to check and make sure we're good. 'Cause sometimes the internet doesn't work the way that you want it to, and your old ISP is not as robust as you hope that it is, and so it can get a little fun. So anyway, all right, good to see some people flowing in here. Mel, good to see you. Dimitri, tea, no coffee left. Yeah, well, tea is okay. Also, let me know. This thing looks like it's getting pretty hot on the mic. So if I'm too loud for you guys, let me know and I'll turn that down too. Um, I find myself leaning into it a little bit more than I do sometimes when I'm recording. So I don't really change the settings there. Ollie, good to see you. CW, good to see you. All right. Everybody's starting to pour in here. Excellent. We'll go ahead and kind of get started then with our welcome. So, welcome. Good to see everybody. A lot of regular attenders here, subscribers to the channel. So good to see you guys hopping in for uh, hopefully hopefully a helpful discussion. Maybe for some of you, maybe something that you already know. I don't know if you saw my post on the community channel earlier this morning. I would have put that up earlier if I had gotten up earlier, but that didn't happen. So, yeah, sorry about that, getting that out a little bit late for everybody, but just wanted to give people understanding of kind of what we're going to talk about today. So, anyway, welcome to the live stream. This is technically a DeepPockets project live stream, even though we won't be talking a whole lot about the DeepPockets project. I think it's the DeepPockets project that's kind of brought us to this specific live stream. And so I wanted to just kind of keep it in the same vein, since there might be others that watch the series later on, the playlist later on, and they might have some of the same questions and same issues at this point. And so we want to make sure and keep that as part of the process here. So hopefully you guys are good to go with what we're doing today. And if you don't know what we're doing today, I'll explain it here in a second. So if you wouldn't mind, hit the like button, and tell other people about it. Spam your friends who are junior developers. What's interesting is, here's a question for you guys. So I know a lot of you guys are self-taught. You didn't go through a boot camp or anything like that, which I love. I think that's awesome that you guys are jumping in there. Maybe that's why you guys are connecting with me when others may not. Is because we're kind of the same in that regard. But one of the what was I gonna say? I completely forgot what I was gonna say. Man, my mind went blank. I need more coffee. Hang on one second. Nope, that didn't work. Anyway, you guys are self-taught, so you probably are not learning things the same way that most people would learn things, and so I know I know that you might have certain experiences that others don't have, but there's also things that are going to be missing. There's gaps going to be in your knowledge, and so I know even from some of the feedback that we got from that real quick live stream a couple days ago, um, which if you haven't seen that, go watch that, because that would be really helpful for me to be able to help you guys. So go watch that other live stream that I did on Thursday. And if you wouldn't mind, leave some comments, leave some answers in there. But anyway, so like this live stream, tell others. Oh, that's what I was going to say. Now I know. Tell others about the channel. Tell others about this specific playlist and series that we're doing on the live streams, and tell others about the Discord channel and the community that we're trying to build here. Because at the end of the day, we're trying to build a community for junior developers, not just right now, but long term. I want you guys to get the knowledge that you need and the help that you need here via this channel, and then stay with us and help others along the way as they come in. Because quite frankly, every year developers are retiring, and old people like me are retiring and getting out of the business, and we need more people coming in. And there's a lot of people, especially right now with junior developers, sometimes having a hard time getting a job. You're going to see a lot of people who went through training and who tried to learn this stuff and wanted to change roles and wanted to get into a different industry. You're going to start to see a lot of them pull away. They're going to start, they're going to decide that it's too hard, or that it's not for them, or that they just can't make it. Or whatever reason, they're going to stop trying. And so, those jobs are eventually going to open up more. And so the ones who wait and persist are the ones who are most likely going to be there in the end. So just a little bit of encouragement for you to do that. But one of the things about being self-taught is, because you didn't go through any specific program, you may not be part of any sort of mentoring. You may not be part of any sort of community. I know that for some people, when they go through like a boot camp, they get some mentoring, they have a community of sorts, even within like their class. Even if it's an online thing, they still have some community there. So I know a lot of you guys are self-taught, so you may not have a lot of relationships with other junior devs. But if you do, share the information, all of that to get to that point. So if you do have relationships with other junior devs or even senior devs, if you have relationships with anyone in the industry or trying to get into the industry, let them know about the channel, let them know about the Discord channel, let them know about what we're trying to build here. Because really the goal is to create a community. It's not just about creating a YouTube channel that's, really successful and all this stuff. That's great if that happens. But at the end of the day, I think the community is really the point that I want to focus on the most. And providing content, providing content is just part of that. The community itself, the Discord channel, and things that we might do down the road, those things really are the key to what we're trying to build. And the YouTube channel is just kind of a way to facilitate that to some degree. So, so go take a look at that live stream that I did on Thursday. Kind of talks about some of that stuff, asks a few questions. So leave some comments on that video, on that live stream. And should be the one that pops up if you go to the channel and you're subscribed. So if you don't see that right there when you go to my channel, then you're probably not subscribed, which means you should subscribe. And if you hit the bell icon, you'll be notified when we do go live, like today. So let's see. See a lot of people give up because they believe AI will do the job instead. Yeah, that's true, Mel. A lot of people are, especially junior developers, are really scared about artificial intelligence and development. What's interesting is when you talk to developers, the ones who are more seasoned typically don't have any fear of AI. And there's a couple reasons for that. One is because we have a lot of perspective and we understand what it takes to actually be a developer and all the different things that are required of a developer. can AI do certain things faster and more efficiently? Sure, but it also takes a lot of work to create AI that does that, to train the AI to do it well and to do it in a way that's going to be beneficial. And so we're not really worried about it taking over our jobs because it can't do what we can do. One of the main reasons why junior devs have that frustration and fear is because you're just learning. You're kind of in the same stage as artificial intelligence in many ways. So you're just kind of learning a lot of the things that are in a way programmed into artificial intelligence. So it has a little bit of a leg up on a junior developer because we've given it the information, but we also have to tell it exactly what we want it to do. And that's the struggle, right? So that's the problem with AI. It's still, no matter what you do, it's still artificial, right? It's never going to be organic intelligence. It's never going to be real intelligence. And so even a junior developer, if they put in the time and the effort, they're going to be better overall eventually than any artificial intelligence that we have. Um, and frankly, you have to have junior developers because they need to become senior developers because you need senior developers in order to build AI, in order to build applications or even use AI properly. Um, I just put out a video. I think it was Wednesday or Thursday. I think it was Thursday on not using Copilot. Copilot's a great tool, but it can really stunt your growth as a junior developer, and it can cause you to actually write some really bad code because Copilot looks at lots of different things. It's been trained on a lot of information with GitHub, a lot of code. But if you think about that, that means you have a fake intelligence being trained by fallible developers. So everything that it's been trained with has been trained with code written by people who don't write perfect code. So none of us ever write perfect code. And so to say that AI is going to replace developers, I just don't see that ever happening, because it's always going to need us to manage it, if nothing else. So yeah, I want to encourage you guys, if you're a junior developer and you're worried about artificial intelligence, please don't be. Um, your goal should be to get good enough at development so that you can use artificial intelligence to make you an even better developer. That should be your goal, not trying to avoid artificial intelligence or skip past it and be better than it. You need to be good enough to use it well, because it is a tool that's going to be here for the long run. It's not just a fad. It's part of what we do. It's part of how we write code these days. And so you will need to get to a point where you can use that effectively and efficiently and not use it incorrectly in a way that's going to hurt your career, keep you from moving forward in your knowledge, but also keep you from writing code that is good and acceptable for the companies that you work for. So yeah, don't worry about AI. Know about it. Be familiar with it. Understand what the good parts and the bad parts of it are. But I would not fear it even as a junior developer. Of course, that's easy for me to say as a senior developer who who can use it. So um, I understand there's some perspective differences there, but I would encourage you to not worry about it. uh, Cat videos, a few million views. Software dev videos, a few hundred views. Yeah, unfortunately. Um, yeah, people are more for entertainment than they are for education a lot of times, especially if you've got somebody, a channel like this where I'm probably not as entertaining a person as some other characters on YouTube or Twitch or other places where you could go to get some of this training and information and knowledge. So that's definitely, entertainment is probably something that maybe the entertainment value probably hurts this channel a little bit. But I think for people who really want to learn and want to grow and hopefully understand that that's my goal is to help them do that. Hopefully they'll get that, and we'll get maybe a few more than 100 views. We'll see. uh, Dimitri graduated from IT Trade School 2007, Tech University 2008, boot camp, ASIC crypto miner repairman. Wow, you've just done all kinds of things, Dimitri. That's awesome. Yeah, forget about AI for at least 10 years. It can code but not program. That is a great perspective. It can code but not program. And that's the thing, that's why you use something like Copilot. You don't want to tell it, "Hey, build me an application that does XYZ." It's just not going to do that. That's not what it's designed for. It's not what it's used for. And so so yeah, I mean it can write code and it can help with writing good code, hopefully, at times. But again, you always have to keep in mind anything that we build as humans, because we're fallible and imperfect, it's going to be fallible and imperfect. So especially if we're building it, and then if we're training it on the things that we do, because we do not write perfect code either, and we do not program perfectly either. So to say that we will ever have a artificial intelligence that's better at doing things like this, nah, I'm not worried about it. Yeah, Mel, in 10 years, you'll be better than AI. Exactly. Absolutely. And that's the thing, get to the point where you can use AI. And that's really what you want to be. Yeah, more like it can partially copy other people's code. Right? Yeah. Now, again, it does have parameters that it uses to understand the code, to understand the logic of it. Um, it can even debug some code as well. So I'm not saying that it's useless. It has usage. Um, but yeah, we definitely wouldn't be worried about it, especially if you're willing to put in the time and the effort to learn and grow. I would really not be worried about it. So anyway, well, as usual, we're completely off base here right at the beginning of the live stream. So cheers to you guys. Mm. We'll blame Mel for getting us off track on artificial intelligence here. All right. So if you are new and you're not completely confused by what's going on right now, just so you know, this live stream is part of a greater live stream, or group of live streams, I should say, that is around a community project that we call DeepPockets. That's our code name. And basically what that is we are building a budget software. Now, there's lots of budgeting software out there. This is not necessarily meant for us to go out there and compete with others. That's not what we're trying to do. We're just trying to build something that is going to be helpful for me because I'm the client, something that I want, and also something that's good for you guys as developers, to make sure that you guys are keeping track of your finances well. Go watch past live streams. I kind of go into that in more detail, why that's good and necessary. But so we're building, it's called DeepPockets. We're building this budgeting software, and we're trying to go from really start to finish on the process. So we have not written any code yet. We will eventually, although the more things that keep popping up, the closer May looks like we'll be writing code. But we'll just see what happens. So, thank you to those who have stuck with the journey so far, but we're learning all kinds of things around the concept of running a project. So if you were to go out there and be a freelancer and find somebody to build an application, I want to give you as many tools as I can and as much knowledge as I can to help you go from starting that communication with the client to building a final product, and kind of see and experience all the things that will happen along the way. And so this is going to be a fairly lengthy project. It's going to be several months for sure. It may even go all the way to the end of the year. I don't know. It just depends on what things pop up as we go along that we need to maybe stop and take some time and talk about. And today is one of those days that we need to kind of hit a pause button on moving forward in the project and just talk about something that a lot of people, especially junior developers right now, don't have a lot of experience with. And if they do have any experience, it was probably very brief in a boot camp or a training course or something like that. And so I want to take a pause today. This is part of the same live stream series, but I want to take a pause and kind of go over some of these, excuse me, some of these topics as they come up. And today's topic is going to be on databases. And last week we were talking about data as kind of a higher, bigger concept, right? How we think about data, how we come up with the data that we're going to interact with in our application, how we think about those things. And so we talked about different types of data, how we get that based off of the features that we want, what we want the application to do will mostly drive the type of information that we need to be able to keep track of. And so we kind of went from there thinking about what type of information that we need and jumped straight into building some database schemas, some tables and layouts and things like that. And as I was looking through some of the ones that were presented in the Dev Mentor Dave Discord channel, as I was looking at some of those and seeing some of the struggle that people were having, and a lot of people were posting their diagrams and saying, feel free to roast it, right? Because you guys know it's not probably anywhere near what we should be doing, and that's perfectly fine. That's part of the learning process, and I'm super grateful that you guys are totally up for somebody jumping in there and ripping it. That's not what we're gonna do today, because I think we need to take a step back and understand kind of how databases work and why we use them and how we use them, specifically relational databases, which is what we're going to use on this project. And all of this may sound completely new to you, and that's great. Actually, that's perfectly fine, because we're going to talk about that today on the live stream and kind of jump into that world of databases, relational databases, a little bit more. For some of you, this will probably be a piece of cake, maybe even a little boring, hopefully not. But if somebody asks a question, feel free to answer it in the chat. And if you are new here, if you have a question specifically for me, put several question marks in front of your question. That just helps me find it faster in case there's a lot of communication going on in the chat. It kind of varies at different points along the way as we go. So that just helps me find those a little bit faster so that I'm not reading every line and giving you a bunch of dead space right in the middle of the live stream. So I want to talk about databases, and it probably is best to start with why we use databases. And for many of you, this may seem really simple and like, duh, which that reminds me. So I left a comment. Somebody left a comment on one of my videos, and I wrote duh, and that was, I meant duh. Yeah, I should have thought about that. But I think they thought I was saying duh as if they were dumb, and they responded back to me. It made me feel bad, like I hurt somebody's feelings. But I typically don't talk like that to people. So, if you feel like I hurt your feelings, let me know, but definitely take a step back and just make sure maybe that couldn't be said a different way or understood a different way, because that's not typically what I'm trying to say. If I'm putting somebody down, usually I'm putting myself down and not you as a commenter or a viewer. So just FYI. Anyway, so back to databases. Why do we use databases? And this may seem like a simple statement, but or idea, but I think it's important that we understand the purpose of it. One of the big differences between a website and a web application is the fact that websites don't need a database. Now, a lot of them are created using CMSs or content management systems, like WordPress or Drupal, or I don't know if Joomla is even a thing anymore. That was a thing years ago when I first was getting started. But they use these content management systems, and those do use databases to store content management system to store the content. But technically a website doesn't need a database. A website could have all that content just hard-coded in the code. An application, however, usually does need some sort of database. And when I say database, what I'm really talking about is persistent information. So information that's going to be stored somewhere, that's going to be able to be accessed from one session to another. So when you use the application today, you may add some information to it, may take some information away from it, and then you leave and you come back and you come back to the application again tomorrow, and you want that data to be the same as it was when you left it, unless there's some reason why it should have changed since you've been there. So a database is necessary to persist, or I say a database. So the reason we use a database is because we want to be able to persist information from one session to another session. Another reason for it is so that we can persist information from one user to another. So when I make a change in the data, I want somebody else to see that change. And so having a database or having some sort of database type entity gives us the ability to accomplish that goal, to make sure that the data is persistent, that it's always there, and that whatever state it was left in is still that way the next time you or someone else interacts with that data. And when you're building an application, that's extremely important that we have a database and that we use the database in such a way that those realities remain, so that we can have data that persists from one session to another, from one user to another, especially if they're interacting with the same information, the same data. And so that's why we have databases. That's why we need databases. Now, when I say database, that could mean a lot of different things. It could be a lot of different things. For example, let me just pop this up over here. So, for example, we've got the responses. I showed this to you guys a couple weeks ago. So this is from the form. If you remember, we've got this MVP features form. Whoop, stop, go. There we go. MVP features form, where we just had a title and a question, right? And this was a way for you to send responses in to that question. You know, what features should be part of our minimum viable product. And so we had the opportunity for you guys to interact with this information. And when you filled out that form, it didn't just disappear, right? It went someplace. And for Google Docs, that went to this spreadsheet. So you could say that this spreadsheet is sort of a database, right? Now, it's not exactly a database. It's not what we typically think of when we think of a database as developers, but it is sort of a database. Even if we just put this into, let's say, a flat text file, that would still sort of be a database. Now, it'd be harder to work with than most databases are, but it's still kind of like a database. The idea is the information is there. It's persisting from one session to another. Multiple users can jump on there and access that. In fact, if you went to the Dev Mentor Dave YouTube channel, you could find the link to this, and you could hop in here. We'd see your little name pop up here, and don't do it now. You can, whatever. But we'd see your name pop up, and you'd actually be able to interact with this data in real time the way that I am. So in a sense, this Google spreadsheet is being used as a form of a database. However, typically, unless you're doing something very simple like this, typically you're going to want to use a more robust solution for your database. And that's where things like relational databases come in. There's NoSQL databases. There's all kinds of different types of databases. But in my experience, most of the time, applications tend to use relational databases. And so I wanted to just take a few minutes and jump into that world and kind of talk about what a relational database is, how it works, and how we need to think about putting information into a relational database. And hopefully, as we talk about this, that'll help you maybe rethink through some of your design ideas from your diagram. Or if you haven't started yet because you didn't know where to start, hopefully this gives you a little bit more help in thinking about your database structure versus just data in general. Now, what is a relational database? So a relational database is you can kind of think of it sort of like a spreadsheet, right? It's a group of spreadsheets that we call tables. Excuse me. And those tables have rows of data and they have columns. And the columns tell you what type of data we want to store for those rows. So if you think about last week, we talked about the different types of data that we wanted in the application that we were building, right? We talked about users, we talked about timestamps, timesheets, things like that. We're gonna switch up, and we're gonna use a different object. If you think about it this way, we when we write a relational database, we're often thinking in terms of objects. Sometimes we'll add things like calculations and stuff like that, but generally the best place to start is to think in terms of an object. So, for example, let's think of a very simple, well, it's not simple, it's kind of complex, but let's think of a simple example would be a car, right? So we have a car object, and we're just trying to think about the attributes of that car object that we might want to interact with, or that we might want to store for future use, right? So again, that's the idea of a database, is we're trying to figure out what information we want to store so that we can use it later, either to change it and manipulate it, or to use it to do some calculations, or just to use it to be able to populate information on a page, right? So what information do we want to see? So if we have a car object or car data, what's the data, the information, the parameters of that object that we're going to want to store so that we can use it later. So I think of things like the make and the model and the year. Those are pretty simple, straightforward. Every car has a make and a model and a year. Maybe we would want to store the VIN number, the vehicle identification number. It's always weird how we say VIN number, but it's in his number. Anyway, okay. So we might want to store the VIN number. We might want to store the color of the car. And this is why I said it could be complex. Actually, the more you think about all the different things about a car that you might want to store, the more options might pop up. But for example, let's just let me jump over to cars.com. Right, this is just the first one that popped in my head. So cars.com, they have a database of lots of vehicles, right? And their vehicles have all kinds of different pieces of information. And so when they built their database out, they knew we're going to need to be able to search for cars based off of certain pieces of information. Sorry. And so the two main pieces of information that you see on this form that are car specific are the make and the model. So when you're going to look for a car, you're going to want to find the model that you're looking for. So like a Chevy Camaro. Yeah, there we go. So a Chevy Camaro. So I need to know in the database, if I'm going to be searching by the make and the model, I need to store the make and the model of every car that I'm going to put into my database so that I can get those cars back out of the database for the listing. So if I hit show my matches, look at all these beautiful Camaros. Oh, that's pretty. And I can't afford any of them. It's awesome. All right. So, but it's pulling a lot of information. If you look, there's lots of information about this car, even just right here. There's a price, there's a location, pictures that are associated with that car. All this information is stored in the database somewhere. And so the question is, how do we design the database so that we can get this information the way that we want, and we can interact with it the way that we want? And so that's what a relational database really does, is it gives us this power. It gives us this ability to do these types of things. Now, there are other databases out there that you can do similar things with, or even the same things with, depending on how you structure it. In my opinion, though, relational databases are the easiest way to do this, and I'll explain why here in just a second, right? So a relational database is basically tables. You can think of them kind of like spreadsheets of rows. So every car that's in the database would be its own row in the relation in the database, the relational database. So it would be its own row, and then every column would be the different attributes, such as the year, the make, the model, the trim, all those different things, the type of engine that it has, all the color, all these different things are going to be part of the information that we're stored in that database. And so I've actually created another Airtables base. I'm finding this helpful for demonstrating things, even if it's not the best way to build an application. I think for some instances, this is kind of helpful for understanding what we're talking about, especially from a database standpoint. Now, they use a database. They use it very differently because they're giving you a GUI, a UI for you to interact with the database itself and create things in the database. So this isn't technically what you would do to create a database, but hopefully it'll help you kind of envision what that looks like, right? All right, so we have multiple columns here. And the first column that you typically have is what's known as the key. And the key is generally a unique identifier. Now, that can be a number like this that auto increments. It just gets bigger. It automatically adds the next number when you add more rows. For example, if I just add a new row here, that is going to auto-populate. See, I didn't type anything in there. It just auto-populated with 4 because I have this set up to be an auto-incrementing number, right? And you could set that up to start at like 1 million if you wanted to, and it would just auto-increment from there. Another way that you could do this would be using, man, it just completely left me. Some other sort of unique identifier. There are there's lots of scripts out there that you can use to create unique identifiers. They could be strings instead of numbers. So there's lots of different ways, but the key thing about a key is that you want it to be unique. You want it to be something that you can use to get to that specific row, that specific entity in the database. So the key is very important. I typically use auto increments. I know there's some people that use GUIDs, it's GUID. So it's a unique ID, but it's usually more variable characters. So a string of unique IDs, and they use different things to create those. But I typically use, and you'll see me use this a lot in our design in our process here. So this is just an auto incrementing, and you want a key. You have a key in a relational database because you're going to need to be able to grab that specific one. For example, let's say I want to look at this specific car. All right, if I'm going to click this, let me hit boom. Now see, they're using a GUID right here. So they're not using an auto increment. If you can see, I don't know if you can see that or not. Nope, that doesn't increase that. But this unique identifier way up here, that's a GUID, right? And so instead of using a specific number, they're using this this unique string. All right, and one of the reasons why it's so long is because it needs to be unique, and they have lots and lots of vehicles in their database. All right, so that unique identifier tells them, hey, I only want the information from this row of data, right? So that's why you have a key in your table. I see chatter, but I don't see question marks. So can you double up, use the timestamp as a key? You can have multiple indexes. We'll talk about indexes here in a second. I would not typically use a timestamp as a key, just because theoretically you could have somebody put two different people input at the exact same time. Now, Does that mean the computer's going to be able to put both of them in at the exact same time? Not necessarily, depending on the database that you're using and how that manages that. So you could do that, but I would rather not have that possibility if possible. So I'd want it to be unique, and timestamps are not generally necessarily a unique value. And so you want your key to be unique, because that's kind of the main identifier for your information, right? So they're using a GUID here, most likely, since that's what we see up here in the URL, to let you know, to let the database know, hey, I want this specific row or of information. Now, their database is probably much bigger than one table, so it's probably doing a lot of other things, but we'll kind of get to that here in a minute. All right, so your database has a key, right? And that key gets you a specific row of information. Yeah, exactly, Dave. We'll talk about indexes here in just a second. I want to get some more columns in here. So I'm going to add a few columns to this. We're going to call this the make. And we're just going to use a single line of text for now. So that's just a variable character. We'll model. Boom. We'll do a year. And for the year, I'm actually going to use a date for that. We're not going to include the time. Create field. And again, keep in mind, this is not exactly the same as a database. This is just to kind of give you a visual idea of how a database works, and how we would interact with it, right? So make, model, year. Let's just go. We'll do one more. We'll do color. All right, and we'll give that a single line of text. Okay, so we now have 4 cars and no information about them. So let's put a little bit of information here. We'll call this a Ford. Ford. What is their hot rod car? I can't believe Mustang. All right, Ford Mustang. We'll call this 2024 and red. All right, then we've got a Chevy. I can type. Camaro. Oh, we didn't get there. Hang on. 2024. Oh, this is why you don't use these things. Okay, so that's also 2020. Hang on. Let's see. I just want a year. You know what? We're going to change this to a number, because I just want. Boom, ba-dum. And that. Okay. Yeah. Okay. So we're going to do 2024, 2022. And it's going to be black. And then let's see, Dodge. What's the Dodge Charger? And then that's going to be a 2020. And it's going to be blue. And we'll just have those 4. So we'll delete this guy. Goodbye. All right. So we're kind of doing the same thing. I've got a little bit of a view over here. So we've got 1, 2, 3. We've got 3 items in our database, and it's not showing any information yet. So let me edit this guy. So we want to see all the fields. Boom, 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 boom. All right. So what we're doing here is we're saying, hey, get the ID, the make, model, year. This is not a good way to represent the year. The year and the color, right? So we're going to publish that. Publish. All right. So we've got our 3 cars here. We got a Ford Mustang, Dodge Charger, Chevy Camaro. Now, again, if you'll notice, we are pulling this information out of the database exactly how it's stored, sort of. There's a little bit of manipulation here, but like I would typically take this data and maybe capitalize this. Maybe we would use this to determine an actual color instead of just, the text. But there's lots of things that's on the programming side. We're just talking about the database, okay? So come back here, look at the database, and this drive me crazy, sorry. This. That's what I want. All right, so we come back here. There we go. That looks right. Okay. Again, this is not a tutorial on Airtables. We're just looking at databases. Okay, so we've got a primary key. So I know that if I'm going to want the Ford Mustang, I tell it to get the car number 1, right? And that's going to give me the Ford Mustang information. If I ask for car number 3, it's going to give me the Dodge Charger information. All right. In the diagram, they use UID. Yeah, that's probably UUID or GUID. Both of those are popular. Okay, so you have your single key for your table. Now, one of the things, again, we're talking about something called a relational database. And last week we talked about the fact that you need to know or understand how your data relates to other data in your application. For example, you have users and they have timesheets, or they have timestamps that they create. So there's a connection, there's a relationship there between that data. And one of the things that we want to be careful about when we make our database is that we set it up to where there are relationships where it makes sense to have relationships. And one of the places that it really makes sense to have a relationship, excuse me, is when you're putting in the same information over and over and over again. Okay, so let's say, go back to our cars.com example, right? So we've got, well, how many was it? Was it 20? Oh, well, let me go back here. It's like 26 or 36 or whatever. 39. We had 39 matches, right, for our search for Chevy Camaros. So they have 39 matches, probably within a certain distance of me. Yeah, 30 miles of me. They probably have lots more than that. There's 39 matches that meet the criteria that I requested from the database. Okay, so there's 39 of these things, and all of them have Chevy Camaro, right? Chevrolet Camaro. They're all using the same make and model. Now, one of the things that we want to be careful of with our database is we don't want somebody to just keep typing this in over and over and over again. Now, could we just put that into a form so that it gets sent in the same way every time? We could, but the question is, how do we populate that form? Do we populate that form based on hard-coded information, or does it make sense for it to auto-update the available makes and models based on what's in a database table? That actually makes the most sense, because then you're not constantly having to update your code. You're just putting new entries or removing entries from a database. So you can have a table that serves multiple purposes. It could be used as the items in a dropdown. Again, if we go back to our options here, so maybe it's new or used. So this is probably coming from a table. That could be hard-coded because it's pretty small, but it may be coming from a table. This is most likely coming from a table when you look at all the different options, and those options might change over time. And so putting them in a database makes it much faster and easier to update this list than to go in and change actual code that might be in your drop-down list for your form. That would be really arduous. So, but it also does something else for us. It helps us do what's called normalization. It helps us make sure that we're not duplicating information that doesn't need to be duplicated. And it helps make sure that that information stays the way that we want it to stay, right? So over here, if I wanted to put in another Ford Mustang, I would have to type in Ford Mustang, right? And then the year, so 1967, and it's green. I don't even know if they made green ones back then. But that is so if I have to do that, I have to do the same way. What happens if I accidentally misspell Mustang? Right? That's not good. If I search for Mustang spelled correctly, then this one's not going to come up unless I know the exact ID. Right? So one of the things that we want to do is normalize the data, or make sure that the data is the same for each vehicle that uses that information, right? So we probably want a make and a model table, or separate tables, right? So that we can control that information So this is where relationships come into relational databases. So let's add a new table. We'll call this makes and save. All right, so I'm going to change this up here. We're going to use this as an ID again because that's what I prefer. Auto number. Okay, so we've got number. This will be the make. We'll just call it make. All right, and we don't need these. Where's my delete? There it is. Delete. Okay, so here, let's say we've got Ford, and we've got Chevy. Oop, not Chevy. Chevy. Come on. And here we go. Oh, that's why. This is a paragraph text. Hang on. Let me do single line. Boom. There we go. All right. Ford, Chevy, and Dodge. All right. So we've got 3 makes. All right. And these are in a separate table. So let's say I wanted to create a form that had a drop down with all of these. Well, now I would pull all of these from that table. All right. Now, where does the relationship come in? Again, this table has a key. So the Ford make has a key of 1. The Chevy has a key of 2. Dodge has a key of 3. Now we can use those keys to relate these makes to our cars. All right, so we can create that relationship there between one table and another table. So let me jump back over to our cars table here. So instead of using a text field here, I can set this up to be what we would call a foreign key. It doesn't really work the same way here in Airtables. It sort of does, but they call it something different. This would be linking to another record. And so Airtables kind of takes care of some of this behind the scenes. So it's not a perfect example, but basically what we're saying is I want to put the key, that ID from another table into this record, into this table, so that they are linked by that foreign key. The key is foreign because it's from another table. Just like I would be a foreigner to many of you because I'm from another country. A lot of you are from other countries other than the United States. So I would be a foreign individual to you, and you would be a foreign individual to me. The ID, the key from the makes table, is going to be a foreign key, but it's a way that we attach one table data to another table. So I'm going to click makes here and link that. We're just going to link one record. Nope, go away. Boom. Okay. All right. Now it's also asking me if I want to add any other fields from that. I'm going to do that just for visualization sake, but that's not necessarily part of what you would see in a normal database. Typically, you would just link by the ID. All right. So we changed our make. So no, there's nothing in here anymore because we removed the strings. So instead of strings, this is now going to be a number usually. And it's going to be, or a GUID, whatever you're using as the key over here in your makes. So we're using numbers, an auto incrementing number. So it would be a number typically over here. So if I want to say that this is a Ford Mustang, I'm going to click Ford and put that in there. Notice it's got the actual ID here. So this is the foreign key of the Ford make. All right. This is other stuff that Airtables does. Just ignore that. Right. So this is really our table right here. So we have a table for makes, and we've now attached the foreign key Ford as our make for the car. All right. Notice from a naming convention standpoint, typically this is singular because we're only adding one, right? So we're just adding one make to the car. This is makes is plural because this is the table of makes, the makes table. So that makes sense. Hopefully when you just think about those correlations and what you're actually doing when you're creating those tables, right? So we have a makes table and we have a cars table. So now this is associated with the Ford make. So if I come over here and on my front end, let me edit this a little bit here. So over here, I'm going to show the make field. And again, this is not exactly how it would work. You'd have to do this with programming, mostly, but I'm using these extra fields to kind of visualize this here. All right, so fields, let's move this field up above the model. Okay. So here we see we have our, I'm just going to leave this here. We have our ID, our key, right? And then we have the make. Now these are empty because they're not associated with any makes at this point because we got rid of the text, right? So let's go back here and associate these with makes. So this is a Chevy Camaro. This one is a Dodge Charger. And this one is a Ford Mustang. Now, this Ford Mustang, if we were just searching for specifically Mustangs, would not pop up. Why? Because it's not spelled right. If we're unless we spelled our search wrong. But if we were searching by the models, then it would not come up. It would not find it because it would not match correctly. But if we search by any of these items here from the makes table, if we use the makes table information to do the search, then we were basically saying, hey, find all of the cars that have the make ID of 1. So now we have the ability to search on this field based on an ID rather than somebody's typed in information. Now, there's times where you're going to look through typed in information, user inputted data, and that's fine. But this gives us the ability to control and normalize the information and make sure that that information is useful for multiple things. All right, so that's really, really important. And again, this field you wouldn't necessarily see in a database. This is just here to visualize what this link looks like, what it's actually doing, right? So let's make a model one as well. So we've got makes, and let's do models. All right, now this is where we're gonna get a little bit more complex, right? We're gonna have to think through what we're actually doing here. Because a model does not stand on its own. A model is related to something else. It's related to a make, right? So, excuse me. So let's edit this. We'll get rid of this one. Boom, boom, go. Hang on. Delete. So this question. So the description of a car wouldn't need a relationship because it's unique. Potentially, Mel. Especially if it's like for example, let's jump over here to the Camaro, right? So if you go in here and you look at a Camaro and you're seeing like this information probably would mostly be normalized. It would probably be stored in the database. But let's see, this seller's information. So like this would be something. Oh, that's the seller info. Well, let's look at these. Customer reviews, right? A customer review would be something that would just be part of your table, whatever table that is, probably a comment or a review table. But this would not be normalized data because it's something that people are putting in. It's going to be generally going to be unique unless somebody is literally copy pasting stuff into multiple reviews. It's going to be unique because somebody inputted it uniquely in and of itself. And even if they were, you're not really worried about this specifically being unique or being normalized because it's somebody's inputted information. Whereas if you know you have standard information, that's where the normalization comes in. You have standard information, like you know you're always going to have these types of makes, these types of models based off of the makes. You're always going to have these types of colors based off the make and the model. You know, all these different things that are pretty much standardized, that don't change or change very infrequently. Then you would be able to put those typically in their own table like we're doing here, so that you can manage them separately. But anything unique, correct. Let's say you had like we wanted a field here that was the uh, owner's description of the vehicle, a current state of the vehicle. Like if they wanted to leave notes about this specific vehicle, then that would be on this table or maybe on a related table just to keep things organized. Again, something to keep in mind is a lot of this comes down to organization as well. It's not just hey, it belongs on this table or it doesn't belong on this table. Sometimes some people would put notes in this table. Some people would put them in a completely separate table that only had note information, and then they would add a foreign key to this table to link them. So some of it's just organization, what makes it easier to understand the database when you're looking at it. So some of this is gonna vary from person to person and how they do it. I'm just trying to help you understand how it actually works and how we use it. And then you can kind of jump from there to organize things the way that you think you would want to organize it for your specific application. And again, that's different. Even among senior developers, I work with a lot of senior developers, and everybody does database design differently. We all think of things in different ways as far as how we would organize the information. What we're talking about here is normalizing it, which is making sure that we're not duplicating as much as possible. So when we look at this information is not really duplicated. It's linked. And there's a difference there, right? So we're not saying these are duplicate because they have the same make. They're not really duplicates. They're just linked to other data that is not duplicated, right? So if we put Ford in here, we would have multiple Fords, and that doesn't make sense for the makes that we have. Something else that we would do here is tell this make that it needs to be unique. I don't know if you can do that here. You can't really do that in Airtables, I don't think. But in our database, we could take this column and we can tell it, hey, this should always be unique. So in a real database, what I would do is if I wanted to come in here and if I added Ford again, it would not let me do that if I told it that this make needs to be unique, because we would have duplicates. So if I say, hey, this make column needs to be unique in the makes table, which is something you would typically want to do, then that helps protect the information and make sure that we only have one of each make in our database. So again, that helps with our data integrity. It helps with duplication issues where we don't need or want duplicate data. And so that's why we use these relational databases. That's why we break out information in other places, especially in cases like this, where we're going to use it over and over again to normalize it and protect from duplicate entries. Because if you have duplication, that bloats your database, makes it bigger than it needs to be, and sometimes may hurt your ability to search for different things. For example, if I have two Fords in here and I say I want to search based on cars that have Ford, well, now I've got to figure out which ID do I use as my foreign key in the search, because one may have an ID of 1 and the other may have an ID of 5, but they're both Fords. So that wouldn't really work. So if we make this unique, then that means anytime I'm searching for a Ford, I can do it based off of this key in our cars table. So that I'll always be looking for just that one key, right? So we're normalizing the data. We're keeping duplicate data away, as much as we possibly can, so that we can be able to use the data in the way that we want to use it in the future. And a lot of that has to do with searching, has to do with updating, manipulating information. So that's the idea of foreign keys. Now, there's another thing that we use called indexes. So you've got IDs or keys. You've got foreign keys, which allow you to connect data from one table to another table, right? It's a foreign key based on the key of the other table. But there's other things that we use called indexes. And what an index does is it kind of stores another way of quickly finding information, right? So think of it as kind of another key. So we've got our unique key identifier here, but an index doesn't have to be unique like a key does. So for example, over here, we've got years, right? So let's say both of these are 2024, right? So these are the same. They're not unique. They are user inputted, though we would probably use some sort of date thing, right, to be able to put them in so they wouldn't be user typed. So we would manage the uniqueness of or the input of them from the code. But both of these are 2024. Let's say I wanted to search the database for all vehicles that are model year 2024. Well, in this instance, that would be really simple because we only have two. But our index is public keys. Mel. I'm not thinking of a public key. Public key is not coming into my mind as far as what you're talking about. I think unless you might be talking about like a Postgres thing. You mean are they visual? Can you see them? As long as you display them, yes, you can see them. And typically you would use them to search for data. Because what an index does is it says, okay, if I'm going to index the year, I'm going to make this column an index. What your database typically is going to do is it's going to create in the back end this kind of secret table or database of the types of indexes that you have, all the unique index information. So it would keep track of 2024, 2020, 1967. It would keep track of those indexes, those values, and it would keep track of which of these keys are associated with that value. And so it's kind of using its own little table to keep track of that information. And the reason why that's helpful is if we do a search based off of an indexed column, such as a year, and we've said that needs to be indexed, then the database automatically knows, hey, I'm going to search this other table that you can't see that's not part of your design. I'm going to search this other table, and I'm going to search that faster because I don't have to search as much information. I don't have to search through all of these, hundreds and hundreds and thousands of rows. I can search through and find all the ones that are associated with this year based on this index. Basically what it does is it gives us a way to search by other columns faster than you would. Now, you can always search, like if this was not an index, you could still search by it in a relational database. It would just not be as performant. It would not be as quick. Now you want to be careful. You want to only index things that you're probably going to search by and that you need it to be quick. Sometimes you don't need it to be quick, right? So you only want to index things that are going to help you with your speed that you're actually going to use. You don't just index every column in your table. That's not a good idea because it does take a lot of effort to build and keep up those other kind of hidden tables, those index tables. You don't want to do that. you want to make sure that you're only indexing specific columns that you know you're going to use specifically, usually for searching. That's the main benefit of using indexes. So we have keys, which are our unique identifiers. We have foreign keys, which are connections from a foreign table to the table that we're currently working with. And then we have indexes. So indexes, again, are records of unique values in a specific column, right? So years we would index. So that way, if we do a search, give me all the 2024. Well, for example, let's look over here at Chevy Camaros again. And let's say I want to search by, do they have year? Minimum year. Here we go. So minimum years, 2024. All right. So I told it I only want cars that are in 2024. And that was a pretty fast response. Now, they probably have lots of good hardware behind them, but one of the reasons why is they probably have that field indexed because it's something that they search by. And so you want to index something that's going to be searched usually because it's going to make that search faster, especially the more data that you have when you've got thousands and thousands, if not millions of cars in a database like cars.com does. Yeah, that's a good point, David. They can also, you can use indexes to sort data. So for example, we could sort this by year, ascending. So 1969 to 2020, 2024, 2024, right? So you can use those to sort. It can get really complicated. Again, this is like super high level information. I'm not a database expert either. I've used them for many, many years. So I'm familiar with them and hopefully can make them understandable to some degree. But I'm definitely not a database administrator. Maybe that's something that you would be interested in. That could be a job that maybe isn't as much, web programming, but maybe data interests you. And this is a good introduction for you to jump in and learn how databases work. And you might find a new niche for yourself. So, okay. So the year is something that we would probably index. It would not be unique because different cars are going to have different years, but it's something that we don't necessarily want to put into another table. We don't have a reason for it to be in another table necessarily. But we want that to be something that's quickly searchable. So we make that an index field. All right. So let's go back to our models though, because we need to understand again some more relationships. And I know we are well over the hour, so this is probably going to go a good bit longer. For those, I know many of you stay on anyway, so it's not a big deal, but for anybody that's watching and you need to get off, we had a little bit extra conversation at the beginning, so I apologize for that, but we're about an hour in, and this is probably still going to go at least another 20 minutes, I would assume, just to get some of this information down and understanding down of the of how databases work. All right, so again, we're thinking about our data. We've got cars, and we've got our car has a make, it has a model and a year and a color. Now, the model is not something that stands on its own. You can't have a Chevy Mustang. All right. That would be anathema for many, many people. Right. So these are not independent values. Right. So when we set up our model table, because we want to control that data, we want to normalize it. When we set up our model table, we're going to have to take into account the make as well as the model, right? Okay, so let's jump over to our models. We're going to make this an ID again. I don't know why this always does single line text. That'd be great if you could tell it to not do that. Maybe there's a way. No, come on. Come on, you can do it. There we go. All right. So we're going to make this the make, because we need to attach our models to a make. And this is going to be linking to another record. So it's going to be a foreign key, right? And then we'll just add this so you can see it again. And then over here, we're going to change this to be the model. Oops. This doesn't have to be capitalized. I don't know why I'm capitalizing it. And then this will just be single line text. And again, there's no way to make this unique, but I would make this unique because I don't think there's any vehicles. I don't think there's any vehicles that share names from one brand to another. So you would typically make that unique. I'm gonna make this lowercase just because that's how I do things usually. Okay, so let's say we're putting in some Ford cars, right? So we've got Ford. So we're going to link, this first one is going to have a foreign key of 1 for Ford. And we're going to put in Ford Mustang. All right. And let's do another Ford car. Oh, I can't search by that. That's annoying. Okay. And this will be a Ford Escape. Right. So now we have two models with the same make. All right. And we're just connecting that make to the model. So one of the things that this helps us with is filtering the models that are available on our form. So if you go back to this guy over here, let's go back and we do do our search again, right? So when we click on Chevy, we've got only Chevy models. Boy, there's a lot of them. All right, so only the models that are associated with Chevys are loaded in this dropdown. That would be a huge pain to hard code. This is why we use databases for that, right? But if I change this to Ford, where's it at? There we go. Ford, all the models change so that they're only showing Ford models, right? And we accomplish that by making sure that our models are associated, they're related to a specific make. All right, so let's go in here. Let's add a Chevy. That's annoying. Okay, Chevy, Camaro, and let's do a Chevy S10. Is it like this? I don't know. We'll use that. All right. So those two different models of vehicles for Chevy as well. All right. So let's go ahead. Probably should do Dodge. Since we've got that as an option. Dodge. Journey. And then Dodge. 3. Okay. Dodge. What do we have in the other one? Challenge or Charger. Boom. Okay. So when we associate this now, we'll come back over here and we're going to change our model to linking to another record. All right. So we're going to link our models here. Now we're only going to allow one record to show. And again, some of this is some UI magic with Airtable. So it's not a perfect example, but I didn't want to dig into an actual database and deal with that stuff, just because it takes a little bit more time. So some of this stuff may not, be completely applicable. So limit. Oh, I can't do a condition here. Stinky. That's annoying. Okay, so we'll just do the make here. Now, in your form, you would typically do some sort of API call to get an updated list. That's what they're doing here, right? Or they're just pulling everything back all in one. But let's say you change this to a GMC. Now you're probably going to make an API call to the backend, and the backend's going to say, hey, give me all the models that are associated with the GMC make, or give me all the models that are associated that have a relationship with the Ford make. All right. So again, this is a foreign key, something that we're going to be searching on. So we're going to be able to find that connection, and it will only return these two records. All right. And so that would populate the information inside of this dropdown. So for our database, if we clicked on GMC, we would have nothing in this because we don't have GMC. But if we clicked on Ford, we would have two options here in this dropdown because it would only pull back the ones that are related to Fords, right? And we can kind of see that if we wanted to build a form here. Let's do it. Let's build a form. Form. Next. Cars, sure. Okay. I don't know if I can do that actually. Blah, blah, blah. Model. Can I do? Yeah. Go away. Specific models. Filter. I can add a filter here. Okay. So add a condition. I can add a condition that says where the make is exactly. Maybe I can't do that. Anyway, what you would do with this model is you would say, hey, only pull back the ones that are associated with what's here, right? So that's kind of the idea. We won't spend a lot of time on that. Come back over here to our database. All right, so that relationship is now in place. So we've got models in their own table, which means that these values will always be consistent. We won't have a misspelled Mustang, right? So we can always search by that. And we have the connection between the make. So in our cars, typically when we would put something in here, we would do model, and we would look it up by whatever matches here. Again, this is not a perfect example here with Airtables, but typically you would want to be putting in something that's going to match. You would limit your selections here to only match the ones that match the selection in the make table or the make column. So we'll just pick one of those here. Boom. Now, oh, why did we do make? Edit field. This should be... We want model. There we go. Okay. So now we can just see that correlation of what it actually is. But this is the actual foreign key. So in a database, when you're building your database, you're really only going to have these columns here, right? So you would kind of ignore, let's do this. You can't see it. All right. So this would really be what your database would actually look like for the cars table. You would see your key, your unique identifier for your row. You would see the make foreign key, the model foreign key, and the year is a non-unique value, right? Something that's just typed in. So you would actually see that. And right now the color is a non-unique value. It's not normalized in any way. So you would see that. So this is what your database would look at. This is what your cars table would look like right now. You wouldn't see this other stuff. You would just know, hey, if I pull this key, it's going to be this. And because you have that relationship already built in, you already have makes in their own table, models in their own table, and those relationships are what you're storing in the actual table. All right. So that's probably maybe the hardest thing to understand when it comes to relational databases and why you separate certain data and how you link that data and why you link that data. Because again, when you're looking at this, if you're looking at this cars table, you have no idea which one of these are Fords, which one of these are Chevys, which one of these are Dodges, right? All you see are foreign keys and a year and a color, right? So in some ways, it doesn't look like it's that helpful. If you're just looking at the cars table and you just want to pull information from the cars table, this doesn't seem like it's that helpful. But what it does is it helps us normalize data. It helps us be able to make data searchable easier by these foreign keys. So even though you can't just look at the database and be like, oh, I know what all these cars are, you have to do a little bit more work. You have to do a little bit more work from a query standpoint when you're making a query of the database. So usually what you'll do is something like join. You'll say, hey, give me all the cars. Let's use our 2024 example, right? Give me all the cars made in 2024. And I also want to also get the make name and the model name, right? So what we would have to do in our query is tell the database, hey, I want all the cars in 2024, but I also want you to get the makes that are associated with those cars and the models that are associated with those cars. So you're saying, I want you to grab the information from this table and the information from this table that matches the information in this row. All right. And that's typically called joining. And we're not going to go into that right now because that's stuff. If you want to learn more about databases and how to interact with them, we'll probably talk about that more later as we start actually using the databases in the project. So that might be an upcoming video, but I want you to understand what you're actually going to see in the database and how that gets split up and why that gets split up. And then how you can get all that information back. Right. So, and get this view, if we pull these back here so that you can see, a little bit more information, we can make these small. So if you said, I want to get the cars that are 2024 and I want to get the makes and the models for those cars, then that query would return something that's more like this view where it would have your make and your make name, your model name, and then your other information about your car. So you would be able to get that information based on the query that you write for your database. And that's a good point, David. There's MS SQL, there's MySQL, um, uh, that you can use. Postgres you can use. Those are the free ones. I would assume we'll probably end up using MySQL because that's the main kind of the more popular, mostly used one. But we'll see. We might jump into something else like Postgres if we feel like it. Um, they're just different. They're different database engines. They're very similar. Mel, she's asking, or I assume maybe not. Sorry. But let me know if that's wrong. Mel, but they say I've heard MySQL are there other two for different devices, not necessarily for different devices, but they're different. They're just different database engines. Think of them like applications. So your database is run by its own application. Um, you're laughing, but you're not telling me the answer. Okay, good. I made a good guess. Sorry. I probably shouldn't guess on things like that. But yeah, so they're just different engines, and those three are very similar, but they do have different benefits. They do some things differently. I'm not going to go into details a whole lot here. I don't honestly know a whole lot of differences myself. I've mostly worked with MySQL. I have one project right now that's currently using Postgres. Um, I've used MS SQL very limited as well, but yeah, they're not for different devices. They're just different engines, and they focus on different things. So one might focus more on performance, and so might have better performance than another one in certain areas such as searches, but others might be better for data integrity when you're updating information. So they're very similar, but they kind of have different reasons different people use them. MS SQL will often be used more with like C#, .NET, people who are working with Microsoft specific, because MS stands for Microsoft. So people who are working with Microsoft development are going to use MS SQL most likely. So that's one thing. You've got MariaDB, that's also a MySQL type database. So yeah, there's lots of different ones, but they're all very similar. If you learn the query language, so how to interact with the database, and we'll probably talk about that some at some point in this process as well. But if you learn the query language to be able to get information out or put information into these databases, they're going to be very similar amongst those three or four that we just mentioned. So yeah, there. By the way, somebody posted a tutorial in the Discord channel uh, about relational databases. That I glanced through it real quickly just to kind of see. I hadn't seen that one, and it looked pretty good. So if you want to maybe take this another step down the road with somebody who probably can describe it even better than I can, check that out in the Discord channel. So yeah. So this is hopefully the goal of walking through this was not necessarily to teach you database design, but more to kind of help you think as you're thinking about your diagrams. Right now, if I'm building a diagram that's for cars, makes, and models, I am thinking through how the data is going to be used. And we sort of talked about that last week, but I felt like we needed to jump into that a little bit more and see that a little bit more with things like cars.com, and just see what that actually is going to look like in a real world database situation. So when you're looking at this database, you're going to see this in the table, right? But when you learn the query language for the database that you're using, you'll be able to join information from other tables, and it will be really easy if you're using these foreign keys to be able to do that. So that's how we normalize data. We make sure that it's the integrity is as good as it can be for what we're trying to do. And again, we break these out for different purposes. Some people just break them out because they don't want certain types of information on here. So like, let's say somebody doesn't like putting um, description fields, long text fields in the same table as other data that's mostly keys or mostly numbers or something like that, just because it's harder to look at when they're looking at the database. That's a perfectly fine. They can go create a description table and link that, and so they all the when they're looking at this data, it all looks the same style across the board. When they're looking at this, it all looks the same, from here to here, and they don't have this weird type of column, so they may do that just more for their own preference. Sometimes, again, we break things out. I would typically call this like a types table. Makes are a type. They're a make type. Something that I'm going to fill a drop down with, so sometimes it's good to have those in their own table so that you can control, for example, let's come back over here to our makes table. We're going to add a status field, right? And this is, we'll do something. This is called a single select. You would do something like this, would be like an enum, where you would designate it only has these optional values, right? So this would be active and inactive. So I'm going to say it should only be able to have the active value and the inactive value. It's still, this would typically probably still be text. So we'll create it. A lot of times with your databases, you can add a default field, a default option, I mean. So let's say default is active, and you can do that in enums. You can do that with numbers. You can do that with most database field types. You can add a default option. So that way you don't have to designate, hey, this is empty, or you can designate that it's empty, that it can be empty. So status, this one's going to be active and this one's going to be active, but let's say I don't want any dodges to be in my listing anymore. So, because I hate dodge. So inactive. So now I can use this status to determine in my query which of these should be sent back to the dropdown. When I'm filling out this dropdown and I say, give me all the makes, I can say, give me all the makes where the status is active, right? And so this gives me the ability to change or choose which items are used from this table, right? And I could even do that even further on. So like I could say, give me all the cars where the make is an active make. That's a little bit more of a complex query. So once you start learning the actual query language, you can start jumping in and doing things like that. But because we have that on the make, we can now use that in our query to even filter out what cars we get back, because the car is associated to the make by the foreign key, and we can run query parameters off of the status of that foreign key, right? So as you can see, this can really begin to get complicated and convoluted. That's one of the reasons why we do this, though, is to break this out so that we can organize and manage types of data in one place as much as possible in a way that makes sense with how we want to use the data. All right. And again, you look at something like cars.com, lots and lots and lots of data points that they give you for searching and things like that. And so their database is huge. They probably have tons and tons of types tables, such as, engine types. And I mean, you just look at, oh, there's no matches for that. We've got your Ford models. There's prices. So they're doing range lookups, searches. So that's another thing that you could get into from a database usage standpoint. Again, I don't want to jump into all the query options. I just want to hopefully give you a little bit better understanding of when we say build a database schema, when we say, create these tables over here in DB diagram, what data do we put where and why do we put it there, right? So instead of a string here, this would be a number, and this would be a number, and year would be a number, and color, I think is what we had, right? Color would be a number. So here's our index. Now let's make another table. This would be our makes. So our ID would be an index, and our make would be a number. Now it wouldn't have to be make. You could just be like name or title or whatever. I think make makes sense. Make makes sense. And this would, and we had status. Again, this would be probably an enum, but we'll just do varchar for now. So again, making these associations. Let me blow this up a little bit so that you guys can see it better. Hopefully, having talked about the database structure, this makes a little bit more sense. So the make is actually going to be the ID, right? So this is going to be, it's a one-to-one relationship, not one-to-many. But you get the idea, you get the connection, right? So this is where that structure comes in. And now we have this cars.make is connected to makes.id. So cars.make is connected to makes.id. That's what we have over here in our actual database. So we have cars make is connected via foreign key to makes ID. All right, so that's where we have these correlations. And then of course we have, let's add the models, right? So table models, and we have ID index. Typically what I would suggest is putting all of your keys and your foreign keys at the beginning of the table. If you're using timestamps, I like to put the timestamps at the end of the table. And then all of your other information about that entity, they're kind of in the middle. I think I mentioned that last week, but hopefully it makes a little bit more sense now when you look at it, to have all your foreign keys here at the beginning and then any other data later. That's not foreign keys. Again, that's not like a hard and fast rule, but that's just something that I've tended to do over the years. It's something that we do at the company that I work for. It's just kind of our standard. So I think it's a good standard. So we have our ID, we have our make. I would usually do something like make ID. So that would be a number. So up here we would do make ID, model ID, since we know those are foreign keys. Calling them an ID just gives us a reminder that it's a foreign key, right? So make ID and then model, model. And that would be a string. Okay, so in this case, we are going to be linking the model. Table cars does not have a column make. I'm confused. Oh, that's because this is area. Make ID, makes.id. Okay, there we go. So I'm going to attach the model ID to this ID. So we have our model, but we've also got makes are attached to this make ID as well. So a model is related to cars and it's related to makes. All right. And again, that's what we have up here. We see that our model is related to our cars, but it's also related to makes. So it's a model is a foreign key on cars, but a model has a foreign key from makes. And so we have multiple relationships. That model has multiple relationships in the database. And depending on how you're using it, how you're searching, how you're interacting with that information, that may become really important for different use cases and different scenarios. So you want to make sure that you set up those connections in a way that doesn't interfere with each other, but in a way that that you can use them. So we've got there's lots of other ways that you can do this. You could do, especially when it gets down to having multiple relationships. So what's an example you would do with cars? So let's say for cars you wanted to add um, something like what's the word I'm looking for? We'll call it amenities, right? So we'll just say table. We'll just do it here in our schema. So amenities. Is that right? Sure. We'll go for it. So an amenity ID would be index. And then we'd have the amenity. Amenity. That would be our car. All right. So we've got an index and an amenity, right? Now, let's say these amenities could be things like power windows, power locks, I don't know, radio, CD player. I'm kind of old school here. Different types of things. And you wanted to associate a car with multiple things. You want to be able to say, hey, this has 3 of these items. Well, in that case, you're not probably going to do anything. You're not going to put the amenities on the cars table because then you'd have to determine how many of those you're going to put into your table. Instead, you want another way of connecting amenities to your cars. And a lot of times we do that through something called a pivot table. And what a pivot table does is it basically just gives you the ability to associate different things in one place, but they're not associated on each other, right? So it's a pivot, it's a place, it's a turning point, right, where 2 things come together. And so we have cars and amenities. So for my car, I want it to be able to have multiple amenities. So I'm going to create another table called the we'll call this the car amenity table. This is the way that we do it at my place of business. We use singular terms and we use them. I'm sorry, this would actually be amenity car. We use them in alphabetical order. Amenity car. All right. There's no hard and fast rule on that. That's just the way that we do things. So this would have its own index, right? Index ID, but we would be pulling in the ID of the amenity. So amenity ID, whoop, and that would be a number, and the car ID, and that would be a number as well. All right. And so then what we've got is we've got our amenity car table, which is a pivot table. So now I can say, hey, I want my Ford and I want my Ford. Oh, I'm sorry, this Ford Mustang, right? So we say we got a Ford Mustang here. I want that Ford Mustang to be associated with power locks, power steering, power doors, right? And so we would have a separate row in this table for each of those associations. So let me show that real fast. Let's say this is not the case, but let's say for some reason you could have multiple makes on a car, which again is wrong. But just for sake of an example here, let's do an ID. Where's my, there it is. Okay. So this will be, let's name this car underscore make. So this will be our pivot table. So this is assuming that we could have one car that has multiple amenities or multiple makes. Sorry. So we're multiple makes. So here we would have the car ID. So this would be car ID, link to another record, cars. Okay. And go away. And then this would be our make ID, link to another record for makes. Boom, boom, boom. Go away. Okay. So we'll just get rid of this one. All right. So this is basically a pivot table. So we're going to say for the car ID, I'm going to add my, see, the lookup doesn't help us a whole lot here because it's not showing the association. But I'm going to do for car 1, I'm going to add make Ford. For car 1, I'm also going to add make Chevy. Again, this doesn't make any sense, but just for sake of example here. So now I have associated car ID 1 with all three of the make IDs, right? So if I wanted to find a car that had these three makes, I would be able to do that. Whereas in this structure, it's a one-to-one relationship, right? And we're kind of getting into the weeds a little bit, but I wanted to give you just another model to kind of think about how data can be related, and how you would do that from a database standpoint. So let's say I wanted to find all the cars that have a Ford make, but if they can be associated with more than one make, I need to find a way to be able to make that association. So the pivot table gives me the ability to attach multiple things to multiple things based on their IDs. So I could come in here and I could say, get all of the makes for car number 1. And through this pivot table, I could get back all three makes. If I got rid of this one, it would only get 2 makes, right? But again, that goes kind of into some of the querying and things like that that's outside of the scope of this. But I wanted you to just think through the data, how the data needs to be stored for how I want to use it. So again, I would not come over here and be like, well, maybe years ago I would have done something like this. I would have done cars, and I would have done make 1, or something like that. Make 2, make 3, make 4. But there's some instances that may be okay in some instances, but there might be others where there is no set number of makes that I would add to this car. So using a pivot table makes more sense because I can add them together ad nauseum, right? I can just do it as many times as I want, as much as I want. I can add those attributes or add those makes to that car. And again, makes is a bad illustration, but we already had that information, so that just made it faster to do it. Right? So we can associate those things in different ways, whereas here you're pretty much stuck with a one-to-one relationship. Which is good for one-to-one relationships. But if you need to associate multiple of the same type of thing, such as an amenity, then you'd want to use something like a pivot table here. So hopefully that didn't just completely confuse you. But gives you an idea, a little bit more of an idea of how some of this stuff works together, how these things are related. And again, how you want to use the data. That's really the biggest thing when it comes to database design, is how are we going to use this information? Not just what information we need. You need that as well. You need to know the information for the entities that you are putting into your database. So you need to know that, but not just what information do I need, but how do I want to use that information? How should that information be broken out so that we can normalize it, to make sure that we can standardize it as much as possible? For example, I'll just give you a quick one for budgeting, right? So for budgeting, maybe what types of line items in your budget would you have? So maybe you have a table that's line item types, and those types are income, expense, saving, debt. Those are just 4 that come off the top of my head. So maybe that's a way that you structure yours. I'm not saying that you should. I'm just giving that as an example, right? So maybe those would go into their own database table. So then you could use that to populate a drop down. Hey, is this a debt line item when you're adding a new line item to your budget? Is this an expense? Maybe it's both. So maybe that one needs to be in a pivot table instead of just on the line item itself. Maybe you need a pivot table for those so you can associate more than one with it. So there's lots of ways of managing that data. And again, no two devs are usually ever going to do things exactly the same way. So there is no perfect or one right way of doing it, which I know, especially for junior developers, can be really frustrating because you spend all this time learning how to do things right, and then you come to things like this and you find out, well, there might be some good rules of thumb, but there's not necessarily a hard and fast, you have to do it this way in order to do it the right way. And so um, that can be a little bit challenging when there isn't a perfect way to do it while you're learning. But this learning to do this will help you think through more things. In fact, I'm probably going to record a video Monday talking about how we think through things, and I don't want to give it away right now, uh, but that's, thinking through, thinking ahead, thinking about how you're going to use the data that you're going to use when you're building out the structure of your database is really, really important. Now, I also want to say that database structure is often an iterable thing. You often are going back and redoing it or changing it because you're not going to get it perfectly right the first time. That's just the reality of what we do. There's a lot of things that we do that we just don't get right the first time, and that's okay. That's part of the process. It's part of building software. But the more you can, the more you can think through what you're going to need ahead of time, the less you have to refactor, the less you have to change later on in the process. And so when you think about your database schema or your database design like this, hopefully this helps you kind of think through that a little bit better, understand a little bit better what these things mean when we're drawing lines from one place to another, how that actually works in the database. Hopefully seeing that a little bit in Airtables. Again, Airtables is not a perfect example for this, but hopefully seeing the way that connects, and then looking at that here on this diagram, hopefully that was helpful to you as you go forward. So next week we will look at some of those database designs. So if you want to update them, feel free to do so. If you want to think through them some more and make some changes, again, I've looked at most of them that were thrown out in the Discord channel. So, and they're all trash. No, just kidding. No, there's some good thoughts in there. Obviously there's things that I would change and do differently. And we'll talk about that some more next week and talk about the features as well. Again, think about your features, think about the information that is going to be necessary for those features to work, whether it's putting information in, whether it's pulling information out, whether it's populating a dropdown from something from the database, such as makes and models, whether it's, all kinds of different things. However you're going to manipulate that data or use that data or view that data, you need to make sure that database is set up in a way so that you can easily do that. You can easily pull it out. You can easily put it in. You can easily manipulate it, update it, even delete it, things like that. So understanding how a relational database typically works should help you with that process moving forward. So hopefully this was a help for you guys and not just a huge waste of time during this process. But I feel like, especially for a lot of you guys who are self-taught, you may not have gone down this road yet. And you may not, the next step's kind of learning, okay, how do I write the query to do that with these databases? That's kind of that next step. And I don't know that we're going to quite go there, at least not right now. We're going to do some more planning stuff first. But that might be something that we delve into a little bit more. But I would really encourage you guys to take the time and delve into databases a little bit more, real databases. I would not encourage you to try to learn database structure here with Airtables. Again, it really doesn't work exactly. It does on the back end that you can't see, but the visualization is not a perfect visualization of a database. So it was more just to help me do something quickly so that you guys could see some of those correlations and things and how that works versus what that diagram looks like. All right, let's see. See if there's anything. Yeah, there's lots of ways of doing it. There are best practices, absolutely, David. there's definitely best practices. So, and a good tutorial on that will walk you through those best practices. So, if you're looking for that information, you should be able to find it pretty easily. But yeah, definitely there are definitely best practices, but even those best practices, depending on who you ask, will change. So that's one of the reasons why I'm always a little nervous to say this is the best practice, because everyone's got opinions on those things. So yeah, but there are best practices, and there are typically ways of doing things that are more efficient, that have just kind of been found to be more efficient over the years. Mel says, I found some drawbacks of the way I do things often leads me to realize why something is considered a best practice. Yeah. No longer write random comments on every line. That's probably a good thing. Yeah. So, and that's just going to be part of the learning process, right? Sometimes you find a best practice for you. It's interesting. I've come up with best practices for myself and found out later that they were best practices that other people had, because the more you use this stuff, the more you do programming, the more you are involved in it, the more you're going to find those things that need to be the same every time, or need to be done this way, whether for speed of coding or efficiency of usage, or efficiency of the code, efficiency of the database, things like that. So there's definitely lots of areas where you can find best practices and follow them, and even find your own best practices along the way as well. So much for that only being another 20 minutes. More like another 45 minutes. But again, hopefully that was a help for you guys, especially some of you that may not be real familiar with databases, especially relational databases. I know some junior devs that go through boot camps only see like NoSQL databases. So this would be a whole new idea and world for you. My keys keep shifting. That's weird. I don't know if you can hear that, but anyway, so hopefully this has been a help to you. If it has, and you think it would be helpful to others, please like it, share it, send it to other people. And again, this is going to be a long-term project that we're building. So, buckle up, be prepared to kind of take some of these pauses along the way. And as we go over some things that might be familiar to you, please join anyway, because like, for example, David on here was very helpful, multiple times, providing some extra information as I was talking, to help clarify some things. And that's really helpful. That's what we want to build, right? So we want to have a community that does that, where it's not just everybody's looking to me and I'm the only authority and blah, blah, that's not what we want. We want to build a community. Yeah, I may be the face of it, and do a lot of the teaching and do a lot of the mentoring and things like that. But we want to build a community where everyone's working together, growing together, teaching each other, teaching new people as they come in. That's the goal for the community. And I hope that you guys see that, want that, and participate in that, moving forward. So if you run into people on LinkedIn or run into people in other, channels or things that you think they would benefit from being a part of this, let them know what we're doing. Feel free to just tell them about it. You don't have to necessarily send them to a specific video or something like that, but tell them about the community, tell them about the project that we're working on, and what we're trying to do with it. And I would greatly appreciate it. So I know we went a long time here on this specific concept. I think it was necessary. I hope that it was helpful in the way that we went through it. Obviously, if you have questions moving forward, if you're watching this later, certainly feel free to leave comments. I read every comment, as long as YouTube tells me about it. I read every comment that I can find on the videos and try to respond, unless there just doesn't seem to be a need for a response. So if you have questions, please leave them in the comment section of this video or other videos along the way. Again, we are typically here every Saturday from 10 a.m. usually till about noon, Central U.S. time. We're 2 hours is probably about our sweet spot. Trying to do most of the content in the first hour. Second hour is usually a lot more like questions and things like that. That could be more random, maybe not related to what we're talking about. But but sometimes it's just long like this. So I am going to cut off here at noon or shortly after here. So we're not going to have time for a Q&A this week. I apologize for that, but I felt like we need to kind of go through a lot more of this information, a little bit more detailed with better explanation than we did the week before, to get some more people caught up on at least the concepts, even if they're not ready to start jumping into database design and working with a database, at least understanding what we're talking about when we use different terminology and things like that. So hopefully this has been a help to you on your journey so far, and hopefully you're enjoying and participating in our project. And maybe we'll get some more people participating when we're actually writing code who don't want to sit through all of these. We'll see. But the code is coming eventually. I promise we will be writing code at some point. So thank you for everyone who has stuck around this far without writing any code yet. Hopefully it's been a help in your journey in learning and growing as a developer, not just from a code standpoint, but from a knowledge and a project management and an understanding and planning standpoint. Because those are the things, really, at the end of the day, those are the things that are going to take you from just writing code to being a good developer. If you want to have a successful career, yes, you can have a successful career just writing code, getting tickets and writing code. But you will have a more successful career if you can learn a lot of these other things and do them and learn them even maybe before you get a job or while you're on the job. If you can grow these other points of knowledge, if you can grow these other experiences from a project management and a project flow standpoint, you will be much better off than most other junior developers who are just learning to write code. You need to learn to write code. You need to spend time doing that. You need to get better at it. You need to get faster at it. But all of this stuff will help you write it faster, know what you're going to write sooner, and then it's just a matter of practicing actually doing the writing, right? So that's why this type of information is important. It's not just about writing code. It's learning all these other pieces of what goes into a project, what goes into thinking through, even when we come down to, hey, I'm writing this function. Well, why am I writing this function? What is the goal of this function? What is the goal? What is the purpose? What do I need to do in this function? What data do I need to interact with? What data do I need to get? When you're dealing with databases, how much data do I get from the database? I've got a video idea that I'm going to be pushing out, hopefully probably recording on Monday. I don't know if it'll go out this next week or not, but how do we decide what data we pull from the database? So there's lots of different pieces to those questions. And I think it's important that we go through and learn that process and get some mentoring on those areas so that you are a better dev. Yes, anybody can just do a select all and get everything from the database, but that doesn't mean it's the most efficient thing to do, nor does it mean that is what you really need for what you're doing. So again, we'll jump into that even more as we go through this project. We'll talk about those things, and there will probably be some one-off videos as we go about some of these topics as well. I know I've got a couple different plans, so hopefully this is helpful to you guys. Again, take a look at that Thursday live stream. I have several questions around that topic of what is helpful, what are you looking for, because I want to make sure that everything, as much as possible, everything that we're doing here is something that is beneficial to you as a junior developer in helping you actually mature and grow to the point that you can be a successful developer. So I'm going to sign off. Thank you everybody for hanging with me. We've had a good number here throughout most of the live stream. So thank you for hanging with me. I've got other things I need to get done today, so I'm going to cut it off here after 2 hours. So I will see you guys, I think, next Saturday. So there are a couple Saturdays coming up that I won't be available, and I'll try to make sure everybody knows when those are ahead of time. I think next Saturday I'm good though, but I'll let you guys know. I assume I'll be here next Saturday at 10 a.m. Central Time, Central United States time. So anyway, have a good weekend, guys. Take the opportunity to go back and reevaluate your database schema. based on hopefully some better knowledge and understanding of how relational databases work, how we use them to store data, and why we store them in certain, why we store them certain ways. So hopefully that's a help to you. Don't forget to go back and leave a comment on the other live stream from Thursday. Yeah, and have a great weekend. Enjoy whatever you're doing, even the coding and the learning. Do it in a way that's enjoyable. Don't just make life hard for yourself. All right. If you're not enjoying it, take a break. And if you still don't enjoy it after a break, maybe this isn't for you. But if you are enjoying it, take a break too, so you keep enjoying it. All right, I'm going to stop rambling. I'll let you guys go. I'll see you guys next week, and I believe. And but again, I'll keep you guys updated. We'll see if we can have. I'll try to get a poll out for some fun stuff later on this week as well. This week being next week. So I will see you all on the next one. So have a good weekend.